Jonathan Rebelinsky is an analytical chemistry PhD candidate in the Department of Chemistry. Jonathan earned a Bachelor's of Arts degree from Grinnell College in Music and Chemistry and works in the Whittakis Weaver Lab, studying prebiotic ions and radicals in the interstellar medium. So with that, I'll hand it over to you, Jonathan.
All right, great. Sounds like I'm coming through the microphone, so hopefully the audio is good. Yeah, thank you so much for coming to this talk. As the title slide suggests, today I'll be talking about when the sky turns dark, understanding how, why, and when eclipses happen. There we go. Cool. I know some people are tuning into this talk just because they're curious about the next eclipse. So for you, here's the information. We've got an upcoming eclipse, which is a penumbral lunar eclipse on March 24th and 25th. This data is all for Cottage Grove. If you're somewhere else, it will be slightly different. It begins at 11:53 p.m. It'll peak at 2:12 a.m. the next morning at a total magnitude of negative 0.13. It'll end at about 4:30 in the morning. We also have a total solar eclipse, which I assume is what everyone here is excited about. I know that's what I'm excited for. And that's on April 8th. Here in Cottage Grove, it will not be a total eclipse. It'll peak at 0.889 magnitude, so most of the way there at 2:06, start at 12:51. So that's the moment the moon will first intersect the sun, and the moon will finally completely leave the sun at about 3:20 p.m. So yeah, if you're curious, where can I go to see totality? Here's a map of where you'll have totality. The sun travels pretty quickly, so it'll likely be within just a couple of moments. So yeah. Plan your trip accordingly. At this point, we're getting to the point that I'm pretty sure most hotels are sold out in most locations. So yeah, if you came here just to know when the eclipses are, where they are, you've got that. Feel free to tune out. For the rest of you, I want to make a quick diversion. Because this is a talk partially about eclipses, but also partially just about science, right? And a lot of people think of science and wonder as being these two combative forces, right? You know, we do science to take the wonder out of the world, to take the joy out of it. Some people might do that. I at least don't think of that at all, right? To me, science is really about that childlike sense of joy and wonder and questioning and questioning and questioning. So yeah, you know, we've got here an image of a thunderstorm, and we can, you know, we know back in the day before we really understood how lightning worked, there were all sorts of models that people had. One of the big ones, right, you know, there were those thunder gods who threw bolts of lightning through rage or whatever. We know now that's not true. And so in some regards, right, like, oh, the world's a little less alive. That's kind of sad. But in other more meaningful ways, that's really exciting, right? We can now ask, why is there lightning? And it's not, oh, some thunder god's angry. It's, oh, there's charged particles in the air, and they slowly built up this huge voltage differential, and then suddenly there was a big stroke of lightning, which means we can do that at home. Now, another digression from the eclipse, which I apologize for. But if you know anything about ancient science or sort of worldviews, there's this big idea of symmetry, right? The common phrase is as above, so below. So this idea that anything you see on the small scale will be replicated on the large scale. Anything you see on the large scale is also replicated on the small scale. You can see this with like a lot of herbal remedies from medieval Europe. You know, this thing looks like a foot, so it'll make your foot feel better, is a very plausible idea to them. So similarly, we're talking about the eclipses. The Earth is big, the moon is big, the sun is big. You know what's small? Atoms. So what is matter made of? You know, that's a great question. It's another example of where science doesn't make the world less interesting, but more interesting, right? There's that classical Greek view of the universe as being made of those four primary elements, you know, fire, water, earth, and air. And somehow all of those come together to form everything we have. And this model lasted a really long time because we didn't have the tools to explore better, and because it has a lot of like convincing arguments, right? You know, solids kind of feel like Earth generally. Gases, yeah, air is basically just one thing. Of course, we know in time we've moved on, and we find now that the universe is not made up of these four things. It's really made up of a bunch of atoms. Atoms, of course, being a Greek term meaning something that can't be subdivided. So we've got our periodic table. This is, I think, an up-to-date one. You can tell how new your periodic table is by looking at the bottom right corner and seeing how many of those are labeled with just random strings of U's and how many of them are labeled with actual names. That's just a little fun fact. So we think, oh yeah, we now know all of matter is made up of atoms, these tiny indivisible particles. If that were where science stopped, that would be a great way of saying, oh yeah, science is about killing wonder. But we didn't stop there. We said, that can't be all that atoms are made of, right? We know that they're made of protons and neutrons now, but even at a further level, atoms are made up of quarks. And what are quarks, you might be asking? That's a great question. More or less, quarks are things that don't really exist, and yet in groups of 3 or other stable groupings, they do exist in the form of all the matter that we know and love. So yeah, isn't that great? We went from how does the universe work? What's it made of? Oh, like earth and fire and water, but we don't really have a clear explanation for that too. How does the universe work? We've got this really clear explanation that doesn't really make sense, which is great. It lets us ask all these questions, still lets us be excited. So again, as above, so below. We've talked about some ways that science hopefully does not kill joy. So now we can move on. We've gone from the small scale, the microscopic, the subatomic even. We can move on to the large scale, eclipses, which I'm sure is what you all plan to tune in for tonight. So first great question you might be asking, what is an eclipse? There's a lot of definitions, right? There's that famous book by Stephanie Meyer. We're not talking about that tonight. In astronomy, we tend to mean it as any time one celestial body, so something up in space, gets in the path of another celestial body as we see it. And as lay people, it most often means either a solar eclipse or a lunar eclipse. Now, we know that's, so, it's any time we can't see the sun or the moon is the very short definition. And as with many very short definitions, a pedantic scientist could poke holes in it, right? You could say, well, I can't see the sun at night. Is it an eclipse every night? And in some meaningful sense, yes. In another much more meaningful sense, no. But that does bring up a great question, right? Are eclipses related to days? And the answer is yes. So there's the obvious one, right? You can't have a solar eclipse at night because we can't see the sun at night. Hopefully that feels reasonable. You can't see if if the moon's in between the Earth and the sun if you can't see the sun. But also, interestingly, you can only have a lunar eclipse during the night. So as it turns out, yes, eclipses are very related to days. You can also predict eclipses. They follow a very regular cycle, and the day follows a very regular cycle, right? It's 24 hours. Eclipses have a much more complicated expression, but it's also cyclic. So you might be thinking, okay, cycles and cycles. Is there a link further than that? And so then we think, all right, what's another cyclic thing we have? And we can think about, months. And what's a month? Months are so hard to define. What's a little easier to define is a month in terms of is a month in terms of phases of the moon, right? Every new moon becomes a new month, or you can do full moon to full moon. The question you could ask is, do eclipses have some relationship to the phases of the moon? The answer to that is also yes. You can only have a lunar eclipse during a full moon, and you can only have a solar eclipse during a new moon. So that combined with days, you might be like, all right, there's 27 and a third days per lunar cycle. There's 24 hours per solar cycle. Do those two cycles working together, is the beating there where we get our eclipses from? And the answer is no. That's still not enough to explain it. So we can take one step further and go, okay, what's longer than a month? A season, right? We've got 4 of those a year. Those feel somehow meaningful. So we can ask, are eclipses related to seasons? And once again, the answer is kind of. This one is much less yes than the rest, right? Eclipse seasons happen about every 5 months. You get 2 eclipses. So that's interesting. So it doesn't correlate neatly to every winter you'll see an eclipse. But on some real sense, right, it's we have winter twice a year. We have winter once a year, but we have an equinox twice a year, right? We have 12 hours of sunlight every day, one day, twice a year. And similarly, we have an eclipse once a year, 2 times. Also good to note, every time you have a solar eclipse, it comes with a lunar eclipse, and every time you have a lunar eclipse, it comes with a solar eclipse. So we've gone and we're like, all right, seasons, kind of, but not really. What's the next largest scale we can think of? We can think of a year. But instead of thinking about a year, we can ask ourselves, what's a day, right? I've just been using that as though it's this meaningful, useful term. Day is a pretty easy concept to understand if we imagine, looking out at the solar system from above. So we can imagine this as a top-down view of the solar system. As with many physical models, we've reduced it only to the important bits. So we've got the sun in the middle, and we've got the Earth as that blue and red ball. And we can see, right, a day is just the amount of time it takes for the ball to spin around in a circle. Pretty easy, pretty standard, nice and easy to understand. Also easy to understand, what's a year, right? A year is just the amount of time it takes the Earth to go all the way around the sun and end up back where it started. One thing you'll note is that a year is just under 365 1/4 days, which means that in the animation, we represent that with, a quarter turn that we then just have to restart. But in real life, that's the reason we have leap years, like this year, is because if we didn't add that year every 4 years, we would end up getting to a point where we slowly and slowly phase off of the actual orbit of the sun, and eventually it would be winter in July, and no one really wants that. So we understand we understand years and days now, and even kind of how they interact, right? It's about every 4 years that we overlap, but then if you really look, it's 0.24, and so that's why it's every 4 years except for every century, and then there's another exception where it's except for every century divisible by 4 or something. It gets complicated, but it works. And in the timescales we care about, we can just say 365 1/4. So then we get to ask the new question, what's a month? As I talked about earlier, month, kind of hard to define. Easiest definition of a month, though, because we have moons. Moons are where most months do come from when you look at cultural histories. So we can think of a month as the amount of time it takes the moon, to make one orbit around Earth. So we can imagine, right, we've got the Earth spinning around the sun day to day, and we've got the moon orbiting around the Earth. One interesting thing, this isn't related to eclipses directly, but you know how every time we look at the moon, it looks like the same face? That's because the moon is tidally locked to the Earth, which means that it's always the same side facing us. You can see that in this image with the blue side of the moon always facing the Earth. And so in this image, you have your new moon at the point where it pauses, where the sun is directly, the moon is directly in between the Earth and the sun, and you have your full moon at the opposite point. And I hope you can see how, with those two things, that's where the shadows would make either the blue part of the moon illuminated or the blue part of the moon clouded. Now, of course, this is a nice, easy way to represent a month. It's also wrong, right? We've got the Earth moving about the sun. And so we've got this new definition for a month, where it's the amount of time, instead of the moon going back to directly beside the Earth, it's the amount of time to get back to a new moon. And these are meaningfully different. There's about a day and a half difference between the two. So the month where we go from moon to the Earth's left, back to moon to Earth's left, where the first pause is in this video, that's known as a sidereal month. Sidereal means relating to stars, so it's the month as you would view it from stars. The other one is known as a synodic month, and synodic months are really what we see here on Earth, right? If we're trying to map a new moon to new moon, we wouldn't wait until the moon was back in its actual same spot. We would have to wait until the moon was in between the sun again. So now that we've talked about moon, Earth, sun, orbits, we'll get to the meat of why we're actually here today, which is what is an eclipse? So the easiest kind of eclipse to talk about is a lunar eclipse. So a lunar eclipse is when we have the sun shining light onto the Earth, blocking out the moon. So we can see, right, the moon will be in a full moon here because it's the side closest. The side facing the Earth is also the side facing the sun. And there are two kinds of lunar eclipse. There are penumbral lunar eclipses and umbral lunar eclipses, based on whether or not the moon is in the umbra or the penumbra. You might be asking, what's the difference between penumbra and umbra? And if you trace the sun's rays, ray tracing, the bane of my life, the bane of many physicists' life, but I've hopefully made it a little easy here, right? So the penumbra is any point that you're partially in a shadow, whereas the umbra is the point where you're completely blocking the sun's light. I don't know if you've ever had like a large light that you've then stood in front of and watched the way your shadows move. If you haven't, I highly recommend doing so. Very fun. Really lets you see this umbral penumbral difference. So yeah, as mentioned, this upcoming March, we've got a penumbral lunar eclipse. So we'll see the moon in a position very much like this. Of course, we're here for the solar eclipse, so let's talk about solar eclipses. So the solar eclipse, similarly, right, we got the sun and the earth. In this case, we have the moon in between the sun and the earth. Hope that makes sense, right? The sun can't be between the earth and the moon, and so that's, makes sense that we wouldn't then see that. So in this case, right, it's a much smaller shadow. You'll notice I didn't give a map for the lunar eclipse. That's because you can see it basically anywhere, because the earth is big and the moon is small. So this is a big image, still not to scale. If it was to scale, all of these lines would be basically straight. So let's zoom in a little and see a couple more details. So we can see, here we've just got the moon and earth. We again have this umbral and penumbral region. So here in Wisconsin, we'd be in the penumbra, which is why we'd see a partial eclipse. That line I showed you tracing across the US, that's the umbral line. So that's the line where you completely block out the sun's light. But of course, there's more. This past October, we had what's known as an annular solar eclipse. And so some of you might be thinking, where does annular fit in? I don't see an annulus on here, which is true. But the moon's orbit is not perfectly circular about the Earth. And so there are times that the moon's orbit is slightly further away or slightly closer. And if the moon's further away, much like if this water bottle's further away from me, it looks smaller, the moon also looks smaller. And so because it looks smaller, there's no point where you've blocked all of the sun rays. And so here on Earth, you'd see the penumbra, like before. In this case, you also see the antumbra. The antumbra is just the region which would be the penumbra if we were closer. So you end up seeing the moon directly in front of the sun, but you can still see the sun, which is really cool and exciting. Now, some of you might be going, well, why do we have eclipses only this often? And that's a great question. You might also be saying, well, what does it look like from Earth? Also a great question. So yeah, I'm going to show you two videos right now. Both are sort of simulations of what it looks like if you keep your eye fixed on the moon at all times. So as the Earth's rotating, you're just staying with the moon, both in a season with an eclipse and a season without an eclipse. So this first one, right, we can see it's about half moon. It's steadily getting darker, going towards new moon. Just before the new moon, the sun and the moon eclipse, they cover each other up. We saw that nice little corona just for a moment, which is scientifically interesting. I can talk about that if you would like later on. And then as the moon gets fuller and fuller, it eventually starts to get covered in shadow. And as it gets covered in shadow, that's our lunar eclipse, right? We start with that penumbral lunar eclipse where it's only kind of dark, and then it gets completely shadowed by the Earth. And then comes back from full moon, back to the half moon, and so on and so forth. I don't know about you. I could watch this video for a while. I certainly enjoyed making it, so I'm always happy to watch this again. We'll just watch the solar eclipse one more time. Wow. All right, so yeah, we can contrast this with another cycle of the moon where it doesn't eclipse. Oop. So yeah, here we've again got this, waxing moon, getting bigger, getting fuller. We're approaching a full moon. And as we approach this full moon, we're like, oh yeah, we're ready for this eclipse. So excited. But we see that we didn't actually get an eclipse, and that's a little sad. And then it starts shrinking again, going towards new moon like we see every month if you watch the sky daily. And we're like, oh yay, we're getting towards this new moon. It's going to be time for a solar eclipse. And we just barely miss it. Just ever so barely miss the sun, and so we don't see anything. So you might be thinking, okay, so how are those different other than in one of these I made it make an eclipse and in one of these I made it not make an eclipse? And there is an actual meaningful answer to this. It's a little hard to visualize in just the one view we have of Earth. So here we've now got three views. On the left, you have a side view. So imagine you're standing in plane with the Earth and Sun, looking into it. In the other one, you're on top, you're gazing down at the Earth and Moon. And then that bottom one is the same image that we've been seeing this whole time. So we can see that here, where the eclipse isn't happening, when the Earth is in the top left view, when the moon is at a full moon or a new moon, it's not in line with the Earth and Sun, right? It's either above or below, depending on the thing. Now, this inclination stays the same throughout the whole year. So as the Earth rotates around the sun, the moon continues to orbit at that same angle. And so we'll get into a point like here, where we actually have the moon intercepting the sun at that point in the orbit. And then, the Earth intercepting the moon in that point in the orbit. And as I talked about, right, it's much easier to have a lunar eclipse than a solar eclipse. One way to demonstrate that, what if we're just slightly off on our angles? This isn't totally to scale, but it's close to scale. So we can imagine a third situation here where we have the moon orbiting close enough that we get an penumbral lunar eclipse, but not so close that we actually, overlap the sun. All right. At this point, I've thrown a lot of eclipse facts at you. You might be thinking, wow, eclipses used to be so cool, and now I understand how they work, and now they don't feel cool anymore. Which brings us to the final part of our talk, Science and Wonder, Part 2. Right? We can think, oh, eclipses aren't cool anymore. The magic's gone. Or we can start thinking about all of the new questions this lets us ask. What are some examples of these questions? I hear the Zoom people shouting. Great question. We can imagine, what if the moon was closer to us or if it was further away, right? There's nothing that says the moon's orbit has to be where it is, right? It could be closer, which would make it look bigger. It could be further away, which would make it look smaller. Both of those situations would have really severe consequences on our ability to view eclipses, to say nothing of the tidal effect or all of the other things that would be bad about that. The important one is the eclipses would be affected. So we can imagine, right, if the moon is further away, it'll always be smaller. We would only end up seeing annular eclipses, like this view on the left, which are pretty, but nothing like the magic of a total eclipse. Whereas if the moon were bigger, we would see more total eclipses, because there's just more chances for the moon to overlap the sun. We can also imagine, okay, this only happens twice a year because of the angles of the Earth and the moon. What if the moon was on a different inclination, right? What if it was bent differently? What if instead of orbiting the Earth like this, it orbited the Earth, perfectly circular, in plane? If it orbited perfectly in plane, every new moon would be a solar eclipse and every full moon would be a lunar eclipse. And that would be really cool on the one hand, but also there's something special about, right? You only get to see 2 to 5 solar eclipses in your lifetime, depending where you are, when you are. And there's something really exciting about this, the novelty, the rareness. So we can imagine a world where these were just as commonplace as a full moon. And I don't know about you, but I haven't heard any news stories about miles and miles of the interstate being backed up because the full moon looked nice. So hopefully I've convinced you, right? Just because we know things about the eclipse, that doesn't mean we've killed our joy about it. That means now we get to ask way more fun questions, other questions we didn't cover here. What if the Earth were bigger? What if the moon were bigger? What if the Earth was further from the sun? What if our rotations were different? That's a really big one. What if a day was longer or shorter? There's nothing physical. There are physical things that set it. There's nothing in orbital laws which mandate how fast the Earth should spin. What if the Earth was tidally locked to the moon, and so we only saw the moon at all times from one point on Earth? You could never have a lunar eclipse in other places. With those thoughts, and hopefully many others, I'm happy to first remind everyone we have 2 upcoming eclipses. This hasn't just been a talk for the sake of informing you about eclipses, but we will actually be able to see these in real life happening. March 24th and 25th for the penumbral eclipse, and April 8th for the solar eclipse. I would be remiss if I didn't give you a slide on eclipse safety. I've also been asked to give a slide on eclipse safety. Don't stare at the sun. There are some people who say it's more dangerous to stare at the sun during an eclipse, and that's in some ways true and in some ways not true. It's not true in the sense that if you, for fun, tend to stare at the sky and oh, I can stare at the sun for 15 seconds and it doesn't hurt, and you only stare at the eclipse for 15 seconds, you'll be fine. There's not more radiation per moment, but the radiation that the pain receptors in your eyes are sensitive to is different than the radiation that actually hurts your eyes. That's a fun little fact you can take. And so one danger of looking at the eclipse is the dangerous rays don't get blocked anywhere near as quickly as the ones which cause pain, which means you can end up staring at the sun too long. If you don't normally have a habit of staring at the sun, this is not the day to develop one. So yeah, don't stare at the sun. is, I think, a good takeaway. Questions?
Just to let everybody know in the room, if you are going to ask a question, to turn your microphone on so the folks on Zoom can hear you, and you will not be on the screen. And similarly, if anybody on Zoom would like to ask a question, just unmute yourself, please.
Sorry, that went much faster than I was planning on.
How many lunar eclipses have you seen in your life, and do you have a favorite?
I can only remember having seen one lunar eclipse, which doesn't mean that I've only seen one. That just means only one's been memorable. So that was my favorite one.
Did
your autism showing?
We had a question from Zoom, it sounds like.
Did you see the last solar eclipse?
I did. It was really great. Day of, I drove down with my family and some family friends. We were like, oh, there's this cute little small town in Missouri we'll go to. We drove by the town. It was completely packed. We said, or we can just drive down the highway until we find a nice spot. And we were trying to do that fun game of, oh no, it's partly cloudy, chase the clouds, try to avoid them. And we ended up right outside a farm when the sun disappeared for a moment. I'm not saying you need to see totality, but I am saying the difference between 10% and 99%, you can, ooh. I think you might need to turn off your, yeah, right. Like if you've seen any sort of a solar eclipse, you can imagine what anything up to like 99% coverage looks like. Totality is just something completely different. The sky actually does go dark. Wild animals go crazy. It's fantastic. You should watch it.
There is a question on Zoom. Can I stare at the sun if I wear those film glasses? What about the paper with a pinhole or slit in it?
Oh gosh. First disclaimer, I am not a doctor. Please don't treat what I say as medical advice. Please don't sue me if I'm wrong. I'm pretty sure the film glasses, yes. I'll say yes, because why else would they give you them? The paper with a pinhole or slit, it's that you don't have to look at the sun. It's how you make what's known as a camera obscura, which is a fun little physics trick that if you have a paper with a small hole in it, you can see an image of what's being projected onto it. How the physics of that work, I'm not entirely sure. They're magical. It's great.
This is my question, not a Zoom question, but I know you're a physicist and not an economist, but you were saying earlier about the economic impact of the eclipse and how that impacts society overall?
Yeah, there was some statistic that came out after the last eclipse that, like $10 billion or something of productivity was lost. And not to get onto a political stand right now, but I don't think we should describe it as time lost for productive. It was time spent really experiencing life as a human, Eclipses are something that humanity has always been like, wow, that's cool. It's something that we still think, wow, that's cool. So yes, there are financial impacts. I know I've also heard stories of all of these small towns, which used to 5 to 10 people coming through in a month, suddenly had 50,000 people clamoring at once. So lots of gas stations ran out of gas. Highways were backed up for miles on end. It's a great way to make new friends.
I have a comment regarding the person who was looking for, will the film glasses be okay? I'm not sure if, I don't know if when you go and get your eyes tested or examined and they dilate your pupils and they give you those glasses, I don't know if those are solar ready, shall we say. In the last eclipse, people were buying the appropriate sun wear, the appropriate glasses, but there were some entities that were selling inadequate ones. So you should make sure that you're getting the right kind of solar glasses. I would order them now, if it isn't already too late.
If you need them, the Madison Department of Astronomy has them with a free will donation. I guess contact either me or the UW-Madison Department of Astronomy if you have questions about that. It looked like there was a question here.
I was just going to say, I believe NASA has a list of what to look for, the wordage to look on, the various brands, and what sort of certifications you should see on the glasses that you're buying.
That's right, there's a certification.
I do have a question.
Yeah.
I would imagine many, many centuries ago, people would see this phenomenon and absolutely freak out. Do you have any sense of what sort of superstitions there were?
Yeah.
That, oh no, the world's going to come to an end, your crops will fail or whatever?
So yeah, way back in 2012, if any of us can remember back that far, there was that whole, oh no, the Mayan calendar ended. Does that mean the world's about to end? And so the Mayans actually had this really great method of predicting eclipses. Their eclipse predictions remained accurate up until the end of their calendar, which was just much like at the end of our 12-month calendar. We throw it away because we don't want to have an infinitely long sheet of paper. They also said, well, it's a pain to carve so much stone. We'll stop it here. We'll make a new one eventually. Political forces happened. The Maya are no more. They did not make a new one. So yeah, right, like, even though we've been able to predict them for a really long time, right, in the, I think even Babylon was able to predict them for a while, they've still seemed really mysterious. And, just because one person knows the answer doesn't mean the whole public knows, right? I'm sure there's one person, at least, who understands, what's string theory. I'm not that person, so him knowing it doesn't make me know it, or her knowing it doesn't make me know it. So yeah, this is the academic way of answering a question, which is to give a long backstory that doesn't relate to the question. To actually answer the question, yeah, there are all sorts of omens about mostly solar eclipses. Lunar eclipses seem to be common enough that I at least haven't seen a ton of superstitions around them. I'm sure there are some, but also it can be hard to tell if that's a lunar eclipse or if that's just, a cloud. But for solar eclipses, I know there's a lot of like, oh, don't fight a battle because you'll die. There's the, oh, we have to sacrifice this thing on this date or else the sun will disappear. I don't know tons of details about them, though. I do know there's a very fun thing where animals tend to react weirdly to eclipses because eclipses are so rare. Total eclipses are so rare, right? This was the second one in my lifetime, quite possibly the only two in my lifetime. It's really hard to do this reproducible study where you're like, all right, we looked at this, species of caterpillar in this town because the caterpillars will be completely gone. And even if they're not, 70 years is a long time for change. No, the next total solar eclipse on the U.S. is in 2044. We looked it up.
That was actually the next question on Zoom. When is the next solar eclipse after the April 8th one?
Yeah, I think there's total solar eclipses elsewhere, right? There's a solar eclipse somewhere on the Earth every 5 months. But the next total one on Earth is total one in the U.S. is 2044. That one I think passes through, much of the Southwest. Also, there's an annular eclipse before then, but again, annular eclipse less cool. We can imagine something in front of the sun.
And prior to this one, the last one was in 2017?
The last one was in 2017. It traced a path that went, instead of going southwest to northeast, northwest to southeast. It intersected at one point, as two lines are off to do. And apparently there's a vineyard. There's a vineyard at that intersection, which was very excited to be able to be at the intersection of both of those.
Hi. My son and I, we went and saw the last total solar eclipse in 17, and I agree with you. There is the difference between totality and 99%. It's like the 1 yard line and a touchdown. It's just, it's amazing to see a total solar eclipse. And we have plans to travel south and see this one. On our last trip, we landed up chasing the sun. We had friends we met with in Lincoln, Nebraska. It was totally cloudy, and we're like, what are we gonna do? So we started heading west and chasing the sun, and didn't have reservations anywhere. I'm on the internet on the way out there trying to find a place. We landed up staying in a cornfield in a farmer who was plotting out little camping spots for people, and we stopped at Cabela's on the way out there, and but it was unbelievable. I want to ask a question. If you mentioned the corona, now that is just the gases from the sun, right? That's not part of the actual sun. That's
So yeah, what is the sun is a great question that we can debate. Corona is generally considered part of the sun, right? It's the part of the sun that's extended. It's much cooler. No, it's much hotter than the surface of the sun, which is weird, and no one quite gets why. I'm sure someone gets why. I don't quite get why. Let me flip back to a photo with the corona. Yeah, so this image on the bottom right. So the corona is much dimmer than the sun itself, so we can never usually see it because it's, cloudy. Or sorry, not cloudy, because if you have like one candle and behind it a very bright, flashlight, you'll only see the flashlight, not the candle. But the corona is actually where we discovered helium, everyone's favorite way to make your voice slightly higher, which is why it's called helium, because Helios, god of the sun for the Greeks. Because the corona has a lot of unique features that the rest of the sun doesn't. One of those unique features is a spectral line, which if you've ever looked up atomic spectra, each atom has its own unique fingerprint. Not to say, oh yeah, this relates to my research, but this does relate to my research, which is we do a similar thing with molecules. We look and see, oh, what's their fingerprint like? So the corona was cool to find because it told us research that it was able to help us find things that we didn't otherwise know about the sun. So yes, the corona is part of the sun, which was, I think, the other half of your question.
yeah, like it's not the core. It's just
Yeah, not the core, not the surface.
I think, if I'm remembering the maps correctly, Carbondale, Illinois is one of the places that's right in the path of totality, and that's a fairly drivable distance. And the totality will be like a little bit more than 4 minutes. So we get a nice long look at it from this area.
Yeah, great travel advice. Thank you.
I'm curious if anybody in the room or on Zoom has plans to go see totality and where you're going.
I plan to.
Well, I've only got 50% of the plan that we're putting together with my daughter and her husband. So we're staying outside in the St. Louis area. And then my son-in-law has campsites reserved along the path of totality in 3 different locations. And wherever it looks like we're going to have sun, we're heading for that first. So we've got a strategy to get close, and then at the time we're going to look, find the actual place where we can see that lovely corona. It was spectacular. It was something. See it if you can. It's amazing.
So I have a question. Is totality longer at the center or the edges of the sort of eclipse arc?
Yeah, that's a great question. The center, right? If we can imagine outside of the center is less than totality, going all the way to 0. As we approach the center, we get to 100%. As we approach further into the center, we get 100% for longer. It's also not the same length across the whole track. I think there's a spot in Mexico where it lasts 7 minutes this time. There are places where you can look up such statistics as which part of the eclipse's track will get the longest portion of the solar eclipse. But yes, to answer the asked question, the closer to the center you are, the longer you see totality, which also means the better your chances if it's a partly cloudy day.
Mark on Zoom is going to Mount Carmel, Illinois, near Evansville.
I remember when we saw the 2017 eclipse, we were prepared and we were staying in a state park. The other people in the state park were also there for the eclipse. Somebody had brought a fabulous camera, a telescope camera, and we could let everybody look at it. A community was kind of formed with us watchers, which was really fun.
Are there any cautions against using your cell phone to somehow view it, you know?
Yeah, much in the same way that you can shine your phone at the sun normally, the eclipse is not more harmful to your phone in that regard. I'm sure if you asked the maker of your phone, they would say don't point your phone at the sun, but I don't think they would say that strongly. Again, I'm not a doctor. But yes, I think generally, yeah, you could, especially during totality, when it's safe to look at, oh yeah, don't stare at the sun. During totality, there is no sun, so you can stare at it, as long as you stop staring as soon as totality ends and don't start before it starts. So yes, you could take photographs with your sun, take photographs of the sun with your phone. It would be difficult, much like photographing the sun normally is.
Is it really obvious then when totality ends and you should put your glasses back on?
Yeah, there's that expression, it's like night and day. It really does, 99% you're like, oh, there's something blocking 99% of the sun. Totality, it really just becomes night for a moment. And then it becomes day again all of a sudden.
As soon as it becomes day, put your glasses back.
As soon as it becomes day, look down, yeah.
Somebody on Zoom said that they were able to watch the last eclipse and they had an app that showed the progression and the explanations on the app.
Can I look at the sun with a telescope if I have several layers of the solar protection glasses?
They make solar filters for telescopes, yes. If you have a solar filter on a telescope, you could look through it. If not, I would very much not recommend looking at the sun through something which focuses the light more intensely. But great question. Thank you for asking. So yeah, this is the path the solar eclipse is going to trace in just a couple short weeks. Or long weeks, depending on how much you're waiting for it.
There's a lot of major cities that it goes over.
Yeah.
Pretty unique.
Yeah, I know some of my friends in the astronomy department are planning to fly down to Texas because it's a desert, so it will be more likely clear. Has the other advantage of also being closer to where you'll get totality for longer.
The map that's up right now, there was a similar map published in Sky and Telescope magazine, and that magazine, I'm sure you can find the information somewhere else too, would talk about what part of the country has the most cloudy days, and more likely to be clear, more likely to be cloudy, things like that, so you can plan if you're visiting relatives or friends or just taking the trip, where you could go. Mm-hmm. I think that up in our area, it's starting to get more cloudy, but that's why we have 3 campsites mm-hmm. reserved for that. And like you mentioned, like someone else in the group here mentioned, the freeways were clogged, all of the rest stops were full. You couldn't find any place to stop. And so we're actually staying another night because we're not gonna fight that traffic going back home. It was too much. So, thank you.
Yeah. Yeah. I will throw my hat in the ring. Is that the term people use for like give my opinion? No. I think that's for like run for office. Anyways, give my 2 cents to that. Get on my soapbox. There we
That's
go.
right, idiom.
I'll get on my soapbox. Find a rural highway. No one goes down them ever. The people who are driving to see the eclipse are often coming from big cities and therefore uncomfortable driving on rural roads. Take advantage of that. This is not legal advice. Again. No is the short answer. I could find one is the long answer. This really is most of the path. You know, the rest of it's in the ocean, so hard to see.
Chris on Zoom asks, can you tidally lock a larger object to a smaller one?
You know, that's a great. So I talked about in this slide about how the moon's tidally locked to the Earth, right? We've got the blue side of the moon is always facing the Earth. And then later I brought up what if the Earth was tidally locked to the moon? I don't know if you can tidally lock a larger object to a smaller object. I think two objects can be tidally locked to each other, and no two objects are exactly the same size, so presumably. But ask your local astrophysicist for more details.
Good question. Thank you, Chris. We have about 12 more minutes if there are any more questions.
With each eclipse, are scientists learning something with each one? What are you looking for in this upcoming eclipse?
Yeah, so that's one of those places where it's a really sad answer for me to give right here, which is eclipses are beautiful and fantastic, and everyone should look at them. Scientists, as far as I know, don't really care about them so much anymore, partially because we've developed really good instruments so that we can look at the sun during the day. We can look at the corona at other time periods, so we don't need the eclipse to do that. And also partially, we've measured corona really well. We've measured the things we can measure during the eclipse really well during the past eclipses. So yeah, it's much like when the moon's really big. It's really cool, but it doesn't necessarily help scientists a lot. Oh yeah, you know, that's true. It helps sociologists. It helps biologists, right? There's the what do animals do during an eclipse. I'm sure you could find a way to write an article, you know, like, oh, I'm trying to think what other sciences there are. You could always do the like, oh, we're trying to publish negative results in papers these days. Do acids react the same way during solar eclipses as not during solar eclipses? The answer should be yes, but I don't know if anyone's actually tested that empirically. So yes and no. No in the astronomy sense. Yes in the biology and social science sense. Not really in the chemistry physics sense. And that's all of science, I think.
What do you know about how animals behave during
Yeah,
totality?
it's this really weird thing where every study gives contradictory reports. So there are trends, of course, you know, not every study can contradict with each other. Trends include, you know, nighttime animals, like animals that hunt at night, will come out of their hidey holes for a little bit. I think the orb weaver spider rebuilds its nest. There's some species of spider that rebuilds its web every day, tears it down at night and rebuilds it at dawn. And so it tears down its web during the eclipse. Lots of things actually act like it's night, you know. So songbirds will go to sleep. Toads and other nighttime creatures which sing at night start to sing. Horses apparently react very strangely. I think a lot of horses will like cluster up into a big huddle. But yes, we do not have good, repeatable findings for what happens to animals during eclipses.
In warmer climates, will bats wake up?
Yeah, I think so. I think bats do fly during eclipses, depending on the place.
Jonathan, you mentioned possibly getting in touch to get some of the eclipse glasses. How should people get in touch with you?
Yeah, my email is Rebelsky, so that's R as in Roger, E as in Echo, B as in Bravo, I think is E as in Echo, L as in Lisa, L as in whatever L stands for, S like sun, K like kite, and Y like yes, at wisc.edu. Once again, that's REBELSKY at wisc.edu. Wisc is WISC. Dot is a period.
Is there a charge?
There's a recommended donation, I think.
Which we can find online?
I'm sure there are details for it.
Send you money.
Yeah, I mean, if you'd like to send me money, I will always accept it. But no, I think mostly they're doing the distribution by hand, so it would be like come to the astronomy department and pick up a pair.
I bought some on Amazon a long time ago, and now I want to make sure that they're certified. With that, I'm going to stop the recording.
Recording stopped.
Well, thank you, Jonathan, for coming all the way to Cottage Grove and
Yeah.
being our first Badger Talk.
Thanks so much for having me. Sorry that talk ran a little slow or ran a little short. But yeah, I had a great time here. First time in Cottage Grove.
Right. Hopefully not the last.
Yeah.
What sparked your passion to get into this field?
Oh gosh. There's a lot of answers to that question. You know, as with all things, we live rich and multivariate lives. The story which sounds best, and so it's the story we're going to go with today, is when I was younger, there was a research telescope near my hometown, and the astronomer who ran that had these summer programs for children. Where he was like, learn about the night sky, you know, look at atomic spectral lines, and then look through the telescope, and it was really cool. I was like, wow, science is really cool. And then here I am, doing astronomy-related stuff. That glosses over a whole lot of details, but it's still nominally true.
In your music degree, what kind of music degree do you have?
Yeah, I have a bachelor's in arts. Mostly I focused on early music and composition.
Do you play an instrument?
Yeah, these days mostly just guitar and singing, but I think I gave recitals on 12 or 15 instruments in college. Yeah, the corona is where we detected helium for the first time.
We're running out of helium, right? Not true? Fake news? My mom had a balloon business in the 80s.
There's the like, yes, in the sense that like, when people say we're running out of helium, we have a very limited amount of helium, which is good enough for cooling like MRIs and all the medical equipment we need helium for. And we're running out of it in large part because the United States has been actively selling off our helium reserves for decades. However, in terms of like, can we blow balloons helium? There's still a lot of that. I also know a lot of the helium people use comes from Russia, Ukraine region, and for obvious reasons, it's difficult to get that shipped here right now. But yeah, so the corona also taught us that the corona existed. I don't know if that was, you know, I'm sure it was theorized before we saw it in an eclipse, but theory and observation are different. Yeah, taught us a lot about the stellar profile of the sun, the chemical makeup. Absolutely. Thank you for having me. Yeah. Oh, I had fun putting this together, you know. Being able to make this animation was way more fun than my normal research. Oh, good.